look at our next section, 2.2 basic differentiation rule. In this section, it's going to be much easier than 2.1 that we find derivative with limit theorem. The first rule is that called the constant rule. So if you take derivative of any constant, you're going to get 0. That's the first rule. It's called constant rule. The second rule is called the power rule. If you have a variable raised to some power, then when you take derivative, you take the exponential up front, and then the variable, the power is reduced by 1. The next rule is called the constant multiple rule. If you have a constant times a function, when you take a derivative of function, you can leave the constant alone and take derivative of the function. Now, if you have more than one function, if they add or subtract to each other, you can take derivative of each function and then add or subtract each other. The next one is the trig function. Derivative of psi of x is equal to cosine of x, and derivative of cosine of x is equal to sine of x. Now let's look at some example here. Find the derivative of the function. Now the first one, I have f of g of x is equal to 8 minus x to the cube. So if you take derivative of each term, derivative of 8 is constant. Derivative of 8 would be 0. I use the constant rule here. The second term, I have to use the power rule. I have a variable raised to some power, x raised to the third power, so I have to bring the power up front, and then the variable reduce the power by 1. So I'm going to have minus 3x to the second, or negative 3x squared. Right? Sometimes you have to apply more than one rule in one equation or one function. Now let's look at the second one. I have y equal to 4th root of x. We don't have any property here that's satisfy this one. So I have to rewrite this. If I'm going to rewrite this, it's going to equal to x to the 1/4. 1/4 and 4th root is the same thing. Now I can apply the power rule. So I have to bring the exponential up front, which is 1/4 x to the 1/4 minus 1. Minus 1, I can write it as 4/4. That's the same thing, right? So that is 1/4 x to the negative 3/4. Now you try to keep the exponential positive. So my answer would be 1/4 x to the 3/4. I bring it down, so my exponential is positive. Alright, now let's look at the third one. I'm gonna have to apply some of the property here. So I'm gonna rewrite it a little bit. So I'm gonna write it as 5/2 x to the negative 3. That's the same thing. 5/2, I bring x to the third up, so it's going to be 5x to the negative 3. Now I'm going to use the constant multiple rule. So I'm going to have 5/2, I'm going to leave it alone. Now x to the negative 3, I'm going to use the power rule. So I'm using constant rule, and then for the derivative of this, I use the power rule. Alright, so I'm going to have y prime would be 5/2. That's the constant. I'm going to bring negative 3 x to the negative 3 minus 1. Right, so that's going to be 5 over 2 times minus 3 x to the negative 4. That is negative 15 over 2 x to the negative 4. Right? I would like to keep my exponential positive, so it's going to be negative 15 over 2 x to the 4th. Alright, the negative here can be with the 15, can be with the 2, can be up front. That's the same thing. The last example, pi is a constant. Pi considered constant. So I'm going to apply constant multiple rule. I'm going to leave the constant alone. Now the cosine of t is the trig function. I'm just going to take derivative of cosine. Derivative of cosine is negative sine. So if you take derivative of this, you're going to have pi minus sine of t. Right? Then I can rewrite this as negative pi sine of t. Alright, I'll see you next section.